All right, welcome to the introductory lesson for the Placerita Sugaku unit that we're going to be doing this time. That is Sugaku, which really means nothing more than that's Japanese for math. Now, let me tell you who's going to be involved with this. So, for those who don't know, I am, where is it? There we go, Mr. Cass, and I'll be one of the people that will be talking to you this time.
And this is Mrs. DeMick. I'm going to be working with Mr. Cass.
Oh, it's not writing, there it is.
This is my first time, so you'll have to forgive me if I'm a little slower than Mr. Cass.
There we go, perfect. So now you see us and know who we are, and we'll go from there. So the first lesson we're going to talk about is about, or the whole unit, I should say, is about transformations.
I know what that is, Mr.
You know
Cass.
what that is?
I know what it is. It's on television, right?
Yes.
All right, I'm pretty excited about this.
No. We're not talking about Optimus Prime or Bumblebee or any of those Transformers. These are different kind of Transformers. Let me talk about what these types of Transformers are.
Nicely done.
Oh, there we go. Pen. I gotta get to the pen. There we go. A transformation, and this is what we're talking about. A transformation is an operation that maps an original geometric figure, which we're going to call the preimage, onto a new figure called the image. So we're going to take transformation is an operation that maps an original geometric figure, which we're calling the preimage, onto a new figure called the image. So why don't you, Mr. Mick, tell us what is the first transformation that we are going to be talking about?
The first lesson we're going to do in this transformation unit, like Mr. Cass said, is translation. Translation is like a slide. I'm going to go ahead and write that.
Kind of like the truck out there right now that we're hearing behind us.
I was wondering if that would...
It's translating backwards? Is that what it is? Okay.
Exactly. So a translation is a slide. Oh, a translation slides from one position to another without turning it. That part's pretty important. Okay, a translation slides from one position to another without turning it. Let me draw you a little picture of that. Let's say we have triangle A, B, C, and he's going to slide that way. Ooh, I want to make him... Now, he's not supposed to change size. He's not supposed to do anything. He should be the same size as the original. So A is still there, B is still there, and C is still there. Okay? And this is the cool part. This is where I know the makers of the Transformer movies were math nerds, because this is called A prime. This is called B prime. This is called C prime. I think that's where they got the idea for Optimus Prime.
Absolutely. So if I'm right, so the original figure is the ABC. That's the preimage.
I like that. Good, I'm going to add that here, Mr. Cass.
And the image would be A prime, B prime, C prime.
Wow, that's fantastic.
All right, very cool. Now, most translations just don't happen randomly. Most of the translations that we're going to be talking about, the translations, are going to happen in the coordinate plane. And of course, everybody knows what the coordinate plane looks like, right?
It has wings and a...
That's a coordinate plane, right?
Exactly.
Oops, no, I guess not. I know, you're all yelling at us now. That's not a coordinate plane. All right, you're right, that's not the coordinate plane. But what we do know is this, that any point from the pre-image, so any ordered pair from the pre-image, maps itself, and that's what the arrow is. The arrow is maps onto a point that's going to be on the image. And that point is actually done with a formula where we say take any x-coordinate and add some number a to it. And then take the y-coordinate and add some number b to it. And that becomes the image point. Now, Mr. Mick, can a and b only be positive, or can they be positive and negative?
No, I think if you have a negative a, it would be like subtraction, like x minus a. And if you have a negative b, it would be like y minus a number.
Sounds good. Absolutely. Let's take a look at some of this and how that works.
Okay, now we're ready to translate. So let's start with the correct notation. What we learned from Mr. Cass is that when you have a point x, y, we can translate it, I'm going to change colors here, using this notation. We're going to slide the x-coordinate to the right 2, and we're going to slide the y-coordinate, little tiny writing here, 5. Can you see that? I hope you can see that. That's a 5. Can they see that?
I think, if not, we're going to do this. We're going to take that, and we're going to actually shrink things down a little bit.
Fantastic.
So now we can fit it all on there. Oh, and we need to go back to the pen. There we go, okay.
Okay, so now I can draw my 5 thanks to Mr. Cass.
There we
so
go.
This is the notation. So we're going to take every x and slide it 2 places to the right, and we're going to take every y and slide it down 5. Why down 5? Because it's a negative 5. So this is our notation, and now we're ready to start in with the actual problem. So let's start with point J. It's at negative 3, 4. Okay, write small, Mrs. Demick, so you don't get too big here. I'm going to slide the negative 3 2 to the right, putting us at negative 1. And I'm going to slide the 4 down 5. It's going to pass over the axis there, and it's also going to be at a negative 1. So we just translated the point J. That's good, but we're not done. We still have 2 more points to go. So we are going to go on to point K. Point K, all right, I learned my eraser. Where's the eraser at? Here?
Yep.
Okay, so I'm learning how to erase. There we go. Old dog's new tricks.
Back to the, there we go, back to the pen.
Back to the pen. Point K is at 1, 3. So that's where we started. Remember, that's the pre-image for the vertex K. And we're going to translate or slide that. We're going to move the 1 to the right 2. So it's going to be at 3. And then this y-coordinate is going to go down 5. So it's going to be negative 2. All right, I think I'm starting to get the hang of this. And the next point we have is the point L. L is at negative 1, 2, 3, 4, and up 1, negative 4, 1.
Now, before you do it, let's see if they can do it. Try this one on your own. So what I want you to do is pause the recording and try to figure out what L is, and then we're going to see if you get it. So pause for a second, and then when you have an answer, start the video again and see if you got it right. Now go.
Okay, so good idea, Mr. Cass. Let's see. Negative 4 is going to slide to the right 2, so he's going to be at negative 2. And 1 is going to slide down 5. he's going to be at -4.
How many of you got that? Raise your hand if you got that. I knew it. We got them to raise their hand.
That's right. Good job, you guys. One last step. I'm going to use my red for my image. Okay, so I actually need to take point J and actually graph -1, -1. So I'm going to make a dot here. And I'm going to call that one, if you remember, J prime. That's pretty cool. And then I'm going to move K. K, the image is going to be at 3, -2. Right there, and that's going to be called K prime. That way you can compare it to the original image at the end. Last, we've got L prime is going to be at -4, and nope, that's the original. It's going to be at -2, -4. And you can kind of see that if it doesn't wind up looking exactly the same size and exactly the same shape as the original, you might have made a little mistake. Oops, this guy looks like he needs an L prime there. Okay, this is a translation. It's a slide, and it's our first lesson in our transformation unit.
So let's see if you guys picked that up. So I'm going to write down this problem. Triangle XYZ has vertices, and you all remember what a vertice is, right? What's a vertice?
A vertice is where two lines meet. They usually make a sharp corner. Ouch.
There we go. That's right. Vertice X, which is -1, -2, Y, which is 6, -3, and Z, which is going to be 2, -5. So those are the pre-image points, X, Y, and Z. Now, I want you to find X prime, Y prime, and Z prime if the rule for our translation is XY goes to X minus 2 and Y plus 1. So pause the video, try this problem, and see if you could figure out what X prime, Y prime, and Z prime is.
Let me try, Mr. Cass. All right, stop me if I'm wrong. But X prime, well, I'm going to go ahead and put it in the notation that you used. You had -1, -2, and I'm going to change that. I'm going to transform it, and I'm going to take the -1 and subtract 2 more. So, oops, I need to go back. Wait, I made a little mistake. This is the original, so that's X. And this over here, back to my pen, this is X prime over here. Okay. Okay, we'll keep going. So -1, I'm going to take away this 2 right here. -1 minus 2 is -3, and -2 plus 1 is -1. Just to keep it fun, I'm changing colors. So we have Y, yes?
Yep.
Okay, Y is 6, -3, and I'm going to change that. And so now Y prime, so I'm going to take the 6 and subtract 2 and get 4. And I'm going to take the -3 and add 1 and get -2. And being super careful here to fit this on the screen.
Actually, watch this. Make it real classy. We're going
Ooh,
to change it to
3
another
colors.
color. And I'm also going to shrink this a little bit so that you can fit your third point there for you. Okay, so now what's Z prime?
Okay, so for Z, I had the point 2, -5. And I'm going to transform that into Z prime. I feel like a superhero already. I'm going to subtract 2 from 2. That's going to give me a 0. And I'm going to add 1 to the -5. That's going to give me a -4. Did I get it?
I think so. I think that's perfect the way that works. So now, let's throw them for a loop. We've been doing everything forwards for them. We've been showing them how to take a point and translate it and where it ends up. But what if we did this? What if we told them that A was the point 3, 3, and then told them that A prime was the point 2, 1. Do you think they could figure out what the translation is?
I think, Mr. Cass, if you look at the numbers, you could see if it went up or down, and you could create the right notation. I think we can do it.
Think so? Okay, so here's what we want you to do. We're telling you that this starts at XY, and we want to know what the translation what the translation rule is. That's what I wanted to say. What is the translation rule? So pause the video and see if you can come up with that. Okay, did you do it? If you looked at it right, you would have noticed that 3 to 2 just takes the x, the 3, which is the x, and subtracts 1 from it. That's how I get down to 2.
Ooh, can I do the Y one?
Go for it.
Okay, I'm going to go back to, oh, how do I pick red? I'm going to go to red.
Click on that and click red. There we go.
Oh, fantastic. Okay, so when I look at the 3 and the 1, it went down 2. So I think the rule here is x minus 1, comma, y minus 2.
Sounds good to me. So now here's what's going to happen. We are going to leave you with a couple of questions. Your group is going to answer these few questions, and when you're done, you got to call one of us over, whosever class you happen to be in. Call the teacher over.
Yes, if you're in my classroom, call me over, and if you're in Mr. Cass's classroom, call him over.
Because otherwise we're not going to hear you. But call us over, and we will check to see if you're right and if you understand what you need to know about translations, and then we're going to give you your first assignment, your first Sagaku assignment, to see how well you do with that. So let's do a couple of questions here. I think the first question will be this. Given quadrilateral, quadrilateral. We're going to have some more points now. Quadrilateral no. Let's do something fun here. Quadrilateral TRAP. Quadrilateral trap.
I think you're setting a trap for them.
I think so too, because we all know what that's abbreviation for is a trapezoid, and a trapezoid is a quadrilateral. Yeah, I know, you all knew all that, whatever. Okay, so T is the point. Oh, but the bad thing is I should have known if this was a quadrilateral or not, but that's okay. Quadrilateral, T is the point -3, -4. R is the point -3, 5. A is the point 2, -1. And I tell you, this will probably cross over each other just because I'm not thinking about it. I'm making this up as I go along. And P is going to be the point -3, -1. Now, no.
Yeah, because you've got
Can't do that.
three x values of -3.
That's not right. It should be, let's go -1, -3. That's better.
You don't want it to be 2, -1, perhaps? If you're trying to create a quadrilateral?
I could. Okay. You know, that's what happens when you make this up. And I know we're driving you crazy here, but let's make this 2, -3. How about that? Whatever it is. The rule is going to be xy goes to x plus 2, y minus 3. So we want you to figure out what is t prime, r prime, a prime, and p prime. We want you to find those. Now, let's do a second question. And for the second question, let's give them 2 points, and they have to write the translation rule for them.
I love it.
So what should our 2 points be? Let's do B is going to be what?
Let's make it 8-4.
8-4, okay. And then we have B prime, which is?
Let's make it -2, 6.
6. You know another thing for prime
What's that?
is the word not.
I
So
did not know that.
This problem really is a B, to be or not to be.
Oh my goodness.
So that's the question.
That is the question.
So we want you to find the rule. All right, so we're going to leave you with that. You have to come up with the answers. Call us over. We'll check on them. And you have just completed your first video. And Ms. Tamik, you've completed your first video too.
I did. I lived through it. They'll live through it too.
Absolutely. We'll see you when you call us over.